In the next video, we're going to be creating a straight line function calculator, like the one you see here. So what we're going to be able to do is create these two movable circles, and we're going to move them around. And as we move them, we're going to create this line that extends throughout the screen, from the far left all the way to the far right, and we're going to find the equation of this line. So the equation of this line is in the form of y is equal to mx plus c. And this is just such a fundamental and basic building block of all maths that come past this. So this is a really important project, and you'll see how much better you're able to understand it when you actually create it through code. Even if you have never done coordinates or functions before, this is a perfect introduction to it. So I'm really excited to get started and build this project. As always, there'll be a link in the video description to follow along. And we're going to start with our classic kind of setup, function setup, where we say create canvas with a windowed in a width and windowed in a height, and draw, where we say create a black background and we say strive.draw tick axes. Now, what we first need to do, or first need to realize, is that this axis system is completely different to this axis system. Here, the origin, our 0, 0 point, is starting in the top left corner. Here, our 0, 0 point is starting in the middle of the page. Above and beyond that, as we go up over here, our y increases, go 50, 100, 150, 200. And as we go down, our y decreases, minus 50, minus 100, minus 150, minus 200. However, over here, as we go down, our y increases. And we can't see this because it's going off, but as we would go up, our y would actually decrease. So we need to be able to change both these two things. And this is just a classic thing in computer graphics. The origin always starts in the top left corner, and the y-axis increases going down. Whereas in traditional math, the origin is in the middle, and the y increases going up. It's all arbitrary, but we can translate one to the other. How we go about translating that is, funnily enough, the name of the function we need to use in order to get this looking more like that. So what we need to do first and foremost is say strive.translate. And then with that, I can specify the new origin of where this is going to be. And now you notice that the origin has moved to this coordinate, 200, 200, right? Previously, the origin was at 0, 0. This position of 200, 200 is still kind of like within our old coordinate system. I could show you that if I do this. If I put strive.draw tick axes before and after I say translate, look at what happens. We can see at the old system, there is coordinate 200, there is coordinate 200, and our new origin, our new 0, 0, is at 200, 200. Okay, so now if we want to put that in the middle of the page, it's as simple as just saying, okay, the width of our page in the middle, so width over 2, and the height of our page in the middle, so height over 2. So we can say width over 2 and height over 2. These are global variables we have access to, which are created after this function is called. So now it's looking a lot better, looking like it's in the middle of our page. The next thing, though, is that our y-axis is still increasing going up, right? Our y-axis is decreasing going up. We want our y-axis to increase when going up. And how we could do that is through something called scale. So we can say strive.scale, and notice if I put 2, 2, what happens? Everything zooms in, right? So everything got much bigger. What scale does is it says, okay, take every x coordinate and multiply it by 2, and take every y coordinate and multiply it by 2. If I made this 4, I'm going to, 4 times the size of my y-axis and only 2 times the size of my x-axis. So you can see it's a little bit squished. This might be more clear if I put this like 1 and 4. Right? So this is saying multiply every x point by 1 and multiply every y point by 4. Right? So our x coordinate is the same, but our y is much, much closer in, as you can see. So the question I would ask you, okay, what could we multiply our y-axis by in order to flip such that minus 50 becomes 50 and 50 becomes minus 50? So 50 times minus 1 is minus 50. Minus 50 times minus 1 is 50. So all we have to do in order to flip it along the y is say strive.scale 1 comma minus 1. And when that loads, now we can get our original axis. And now we can see as y increases, or as we go up on the page, our y increases. Perfect. So we have the same kind of axis simply from these two commands over here. Next, we need to actually draw a point and our line. What this looks like is the following. We need to create a global variable. I'm going to call it let P1 over here. And then inside of setup, we initialize it, right? So this is usually a kind of pattern. You create a global variable, you initialize it inside of setup, and then you draw it to the screen inside of draw. So I can say P1 is equal to strive.draw movable circle. And I can specify its coordinate. So I'm going to say, let's say 100, 100, and I'm going to give it a diameter of 20, very similar to a regular circle. And then inside of draw, I'm going to say P1.draw. And now, when that runs, if it runs, oh, we need to strive.create movable circle, not draw movable circle. Hopefully now this works. There we go. Okay, cool. So now we have a movable circle. And now you can see as I hover over it, it changes color red, and I can move it across the screen. We aren't able to do this with a regular circle, right? If I just do a regular circle, 100, 100, 10, we're going to see two circles, but only one of them is going to be able to move, right? There's that other one, but I can't move that one, right? Because we specify this one. So this is a special type of circle that needs to be initialized in kind of your global scope. Or rather needs to be declared in global scope, initialized inside of setup, and then told to draw inside of draw. Okay, so now we have 1 point, but we need 2 points, right? So that's the one, that's the other. So let's put that in. So in order to get another one, we just can duplicate this logic. So I can say let P2, and then I can say P2 is equal to strive.create movable circle. And I can specify its coordinate. Let's go -100, comma 20. And over here, I'm going to then go again, P2.draw. And now when we run this, let's get rid of this circle as well while we're at it. And we now have two beautiful movable circles. Okay, now the next thing is how do we get this line over here to go across? So the command for a line in P5 looks like the following. You say line, and you say x1, y1, x2, y2. So it draws a line connecting those two coordinates. So I actually can get the x and y coordinate of P1 and P2 by simply saying P1.x and P1.y, or P2.x and P2.y. So I can say line P1.x, P1.y, and I can say P2.x, P2.y. So this is saying draw a line from P1.x, P1.y to P2.x, P2.y. You can't see it right now because it's black, but if I make it stroke red, right? We say stroke here because stroke defines kind of an outline. Fill is for the inner one. We now get this line that joins these two. Awesome. We're starting to make progress. We're flying through this. The next question is, how do I get this line to carry on over here? Right? Notice we got this line to go through these 2 points, but it's carrying on throughout our screen. How do we find what our x and y coordinates are over at the edges, right? And this is where now math starts to come in. So in order to find this point, right, we kind of know what our x coordinate is at the extreme, right? We know it's like either maybe -300 or 300 on the extreme here, whatever it might be. It's going to be like the width over 2 is going to be our extreme x coordinate on the right side, and negative width over 2 is the extreme x coordinate over there. What we need to be able to find is what is the corresponding y coordinate to that x coordinate in order to draw this line throughout the page. And how we do that can be quite tricky in the sense of like if I just say line, let's say I'm going to go from P1 over here. So I'm going to go line P1.x, P1.y, And then I draw, from that point, I go to position and say 200, 200. Okay, when that runs. Now we're getting that line, right? And this looks kind of right in the sense of if we maybe just said, okay, 300, 300, it would be the straight line. But notice what happens the second I move this, in the sense of the kind of angle of these lines is not equal. It's like disruptive or disjoint, whatever you want to call it. But it goes like this, and they'll, right? We don't want that. Notice what it looks like over here. It's one smooth straight line. So how do we go about finding that? And the way we do that is through gradients. It's through saying, okay, the gradient from this point to this point must be equal to the gradient from this point to this point. If you don't know what that means, don't worry, we're going to explain it. But that's how, or the math behind how we're going to do this.